Alright, y'all, so let's take a look at how to interpret your enterotubes. So you'll get your enterotube back, and it will look, hopefully not like this, but it'll look something like this. You'll have some colors in the different chambers, and they will be different from what we started with. To interpret that, you'll have one of these little sheets here, reference charts. The top row is what it looked like before it was incubated, before anything was put in it. And the bottom row is what it would look like if there were a positive result in each of the chambers. So for instance, a positive result for glucose would result in a yellow color. There's also for glucose looking at gas production, and it shows here like it's sort of a little squiggle sort of thing. Look for a bubble, and that may or may not be easy to see in yours. Taking a look at the example one here, you can sort of see a bubble that's formed there. It's a little bit harder because this has been frozen, and so it's not as easy to tell what's been a bubble and what is just the result of freezing, but you can see a bubble there. That means that gas production has happened. So this is something that can metabolize glucose. Most stuff really can, and does so fermenting it to produce gas. The next one, then we take a look, we have lysine. And lysine, if it's a negative test, will look yellow. And we take a look here and we can see that sure enough, we have yellow. So that's a negative result for lysine. Ornithine, same thing. These are amino acids. They're just, if they are metabolized, you'll see a color change. Neither of those have been metabolized, so you don't see it. The hydrogen sulfide / indole chamber, a little bit weird, because it requires some close looking. But you can see there's no change in there. If there were hydrogen sulfide having been produced, we would see down in the bottom of this, we would see a sort of like blackish precipitate. Now there's nothing in there. What we're going to be doing is also poking a hole in the top and adding what's called Kovacs reagent. And we just add a couple of drops of that and see if we get a color change. The stuff that we add, if it turns red, then we have a positive for indole, and et cetera, going down the line. So we're going to take a look at how to score this. Okay, so to score it, you have this sheet here. And it's really just as simple as going and seeing if it's positive, then you circle the number. If it's negative, you cross it out. And then when you finish with the first section, you add all the positives, and then move on to the next one. So you don't subtract the negatives, you just count the positives. So for instance, with this one, we can see that we do have fermentation of the glucose and we also have gas. So we circle the 2 and the 1 and we add them together to give us 3. If the paper will sit still. Yeah, that's a beautiful 3. All right, so let's take a look at the next one then. We have no result for lysine, nor ornithine, nor indole. So nothing there, so we just cross out the lysine, cross out the ornithine, and cross out the hydrogen sulfide. So that gives us a score of 0. Now, just so you know, this is not necessarily what your tube is going to look like. Okay, this is just an example of how to score them. So taking a look, we see that there's no indole there. Now that's because I haven't added the Kovacs, but we're just going to pretend we had no result there. The adonitol, we see no change, but we do see a change with the lactose, right? We see that instead of the red that is here, it is yellowish. And it might not be as yellow as this, but there's a change. So that means that we're positive for lactose. So we cross off the adonitol, circle the lactose, and that means that we have 1 for this grouping. Now, take a look, arabinose, positive, sorbitol, negative. And let's take a look and see the VP we'll talk about here. We'll just go down, arabinose, positive, circle, sorbitol, negative, cross it out. Now, the VP there is Voges Proskauer, or I'm not sure if that G is hard or soft, but anyway, It is a confirmatory test, which we're not going to bother with. Because of that, we're just going to leave it out. As you can see, it's blacked out here anyway. And when we look at how to do the code interpretation, we'll see what that means for our results. If we were doing it, you can see that a negative result would be, well, like it is. No color change there. And positive, we'd be adding a reagent which would change color and it would be red. But again, we're not doing this anyway, so don't worry about that. We can see we have dulcitol / phenylalanine, and there's no change here. If there were, then if the dulcitol were being metabolized, we would see a yellow color. If phenylalanine instead is it's testing for, then we would, it would look like that. It hasn't changed, it's still green. So we go down here and we see dulcitol, no. Phenylalanine, no. So that gives us a total here of 4. Now the last bit, we have the urea test here. You can see that urea has changed. Indeed, it's certainly no longer this neutral color. It's pinkish, almost purple, really. So that is a positive for urea. So we'd circle that. And citrate. Take a look. Citrate. It's not green anymore. It's blue. Blue means that it's positive. So circle that, and we end up with a score of 3. Okay, so we have scored our tube, right? This score becomes a code, and we can use this code to look up what bacterial species is the most likely one to be in this tube, assuming that it's only one species in here. So we're going to take a look at how to do that.